Imagine holding a sleek aluminum frame in your hands, light as air, yet strong enough to carry your weight, your safety, even your life. Now think about this. That frame began as ordinary rock buried deep beneath the Earth's surface. Most people never think about it, but aluminum doesn't exist in pure form in nature. It must be violently extracted, chemically stripped, and forged under extreme heat. And here's the shocking part. Producing just 1 kilogram of aluminum can consume more electricity than running your home for an entire day. So how does raw earth transform into precision-engineered frames used in bicycles, windows, aircraft, and beyond? Stay with me, because what happens next will completely change how you see metal forever. We're about to step inside one of the most energy-intensive, technologically advanced manufacturing journeys on the planet. You'll witness molten metal glowing brighter than lava, machines shaping solid aluminum with micron-level precision, and engineers pushing the limits of physics itself. But here's what nobody tells you. Every frame carries invisible layers of science, pressure, and human expertise that most eyes will never see. From roaring smelters to silent robotic arms, this journey is anything but simple. And just when you think you understand it, the process takes a turn that surprises even seasoned engineers. Everything begins with a dull, reddish rock called bauxite, mined from countries like Australia, Guinea, and Brazil, together producing over 70% of the world's supply. Imagine massive excavators tearing through tropical soil, pulling out tons of ore that contains only about 30 to 60% aluminum oxide. That means more than half of what's mined gets discarded or refined away. The journey from mine to refinery can span thousands of kilometers, often traveling by ship across entire oceans. And here's the twist. Before aluminum even exists, it must first survive one of the harshest chemical processes in modern industry. At the refinery, crushed bauxite meets a chemical bath of sodium hydroxide at temperatures around 150 degrees Celsius, or 302 degrees Fahrenheit. This process, known as the Bayer method, dissolves aluminum oxide while leaving impurities behind like unwanted guests. Thick white slurry forms, bubbling and steaming like something alive. What emerges is a fine white powder called alumina, nearly pure, about 99.5% aluminum oxide. But here's the catch: this powder still isn't metal. To become aluminum, it must endure something far more extreme. Now comes the real energy monster, the smelting process. Alumina is dissolved in molten cryolite and blasted with electricity at around 950 degrees Celsius, or 1742 degrees Fahrenheit. Think about this. Electric currents exceeding 300,000 amps flow continuously, ripping oxygen atoms away and leaving behind pure molten aluminum. The glowing liquid collects at the bottom like a hidden treasure, ready to be tapped. But here's something most people never realize. This step alone accounts for nearly 75% of aluminum's total production cost. Once extracted, the molten aluminum gets cast into massive ingots or billets weighing up to 20 tons each. These solid blocks travel across continents, by rail, ship, and truck, before reaching specialized frame manufacturing facilities. Every kilometer adds cost, energy, and time. And just when you think the hard part is over, the real precision work is about to begin. Because turning a heavy ingot into a lightweight frame is where science meets artistry. Inside the factory, aluminum billets are reheated to around 400 to 500 degrees Celsius, or 752 to 932 degrees Fahrenheit, until they soften just enough to be shaped, but not melted. You can almost hear the hum of heat radiating through the metal. Then comes extrusion. Immense hydraulic presses apply forces exceeding 15,000 tons, pushing the softened aluminum through steel dies. In seconds, solid blocks transform into long, hollow tubes, the skeleton of future frames. And this is where it gets truly extraordinary, because the shape must be perfect on the first try. These freshly extruded tubes cool rapidly, sometimes with air jets or water sprays, locking in their structure within seconds. But here's something surprising: even a slight temperature difference can warp the metal or weaken its strength. The tubes are then cut to precise lengths, measured down to fractions of a millimeter. The sound of saw blades slicing through aluminum echoes sharply through the factory. Yet the real transformation hasn't even started. Next comes bending and shaping, where machines and skilled operators curve the tubes into complex geometries. Hydraulic benders apply controlled force, measured in tons, to avoid cracks or distortions. Some bends take only seconds, others require careful multi-step adjustments. You can almost feel the tension as metal resists, then slowly gives in. But here's the twist: one wrong angle, and the entire piece becomes scrap. Now the pieces come together through welding, arguably the most delicate stage. Skilled welders use TIG welding at temperatures exceeding 6,500 degrees Fahrenheit, creating arcs brighter than the sun. The smell of heated metal fills the air as molten aluminum fuses joint by joint. Each weld must be flawless, strong, and smooth, because even microscopic defects can cause failure under stress. And what happens next determines whether the frame survives the real world. After welding, the frame enters heat treatment ovens reaching 500 degrees Celsius, or 932 degrees Fahrenheit, for several hours. This process realigns the metal's internal structure, increasing strength and durability. Then it cools slowly, sometimes over hours, to prevent internal stress. It may look finished, but inside, the metal has completely transformed. And just when you think it's ready, it faces its toughest challenge yet. Now precision takes over. Robotic arms equipped with CNC systems carve, drill, and refine every detail to tolerances as tight as 0.02 millimeters. Laser scanners sweep across the frame, detecting imperfections invisible to the human eye. AI-powered vision systems analyze thousands of data points in seconds. But here's the surprising part: even with all this technology, machines still rely on human judgment at critical moments. Quality control pushes each frame to its limits. Stress tests simulate years of use in minutes, applying forces of hundreds of kilograms repeatedly. Some frames bend, some crack, and those failures teach engineers how to improve the next design. Rejection rates can range from 2% to 5%, depending on precision level. And this is where it gets intense, because even a perfect-looking frame might hide a flaw deep inside. Finally, skilled inspectors step in. They run their hands along weld seams, feeling for irregularities no machine can detect. Under bright inspection lights, every curve, every joint gets examined. It's a quiet moment after all the noise, a human connection with precision engineering. And what they decide in seconds determines whether that frame reaches the world. Globally, aluminum production exceeds 70 million metric tons every year, with China alone contributing over 55% of that output. The market value surpasses $150 billion annually, supporting millions of workers worldwide. Think about this: if you stacked all aluminum frames produced in a year, they could circle the Earth multiple times. And yet demand keeps rising, driven by lightweight engineering and sustainability goals. 50 years ago, aluminum frames were rare and expensive. Today, they dominate industries from transportation to architecture. Recycling now supplies nearly 30% of global aluminum, saving up to 95% of the energy required for primary production. But here's a shocking fact: aluminum can be recycled infinitely without losing strength. That means the frame you hold today could have lived multiple lives before. Looking ahead, engineers are developing ultralight alloys and AI-driven manufacturing systems that could reduce waste by over 40% in the next decade. Imagine frames that are stronger, lighter, and smarter than anything we've seen before. But here's the real question: how far can we push this material before we reach its limits? From raw earth to refined precision, you've just witnessed one of the most complex transformations in modern manufacturing. What started as a simple rock became a structure engineered to perfection through heat, pressure, and human ingenuity. And now, every time you see an aluminum frame, you'll know the hidden journey behind its silent strength. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of Human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video. Subscribe to the channel, and we'll see you inside the next factory.